What we're doing is solving polynomial equations. In order to solve the polynomial equations, we have to make sure that we're going through this step. Step number one is very important, even if it's not possible, okay? You have to make sure that you don't skip that step. If you skip the step, and you weren't supposed to skip the step, then you're not really going to get very far, and then you're going to cry, and nobody likes criers. So,
what about like crying?
we shall follow the steps on the paper, and then we shall whiteboard. I will tell you when to whiteboard.
I know.
Okay, first step. If possible, factor out a greatest common factor.
No.
No. No. Okay. Use the rational root theorem to make a list of possible rational roots.
What's that again?
Exactly.
It's like conjugate roots.
I can see you study the vocab.
Yes.
Alright, possible rational roots. In order to find the possible rational roots, you need to identify the leading coefficient and the constant. The leading coefficient is the number in front of the x with the largest exponent. So in this case,
1.
1. That is q. List all factors of q.
1.
Positive and negative 1. Okay. Then you need to know the constant. Our constant is 4.
That's P.
That's p. List all factors of p.
1, 2,
1, 2.
Okay, all of these positive, all of these negative. Don't forget the plus minus.
I never forget. If I do.
Okay. The possible rational roots are all the p's divided by each q. So, you're going to take each p and divide by each q. Now, there's only one q, so you're basically taking the p's and dividing by 1, which is basically the p's.
Mind your P's and Q's.
Now, I'm going to list them out individually so that we can see exactly what our possibilities are. So, 1 is a possibility, negative 1 is a possibility, 2, negative 2, 4, and negative 4. How many possibilities do we have?
6.
6 possibilities. Of those 6, at least one of them is going to work. Okay, I'm guaranteeing at least one will work for each question.
How do we
That's
determine
about it.
which ones work? Do we just have to plug them in constantly? Because that seems hard.
We're getting there.
You just grab.
Okay. Step 3. Use Descartes' rule of signs to determine the number of possible positive, negative, and imaginary real roots, and then we're going to make a chart.
What's that?
Alright, so
Exactly.
Oh my god,
First
we
off-
learned it yesterday.
Alright, so Descartes' rule of signs, there's 2 parts. Part 1, you're going to look at the original
You can't because of my teeth.
and its functions, terms, positive or negativeness. Okay, so positivity
plus,
or
minus,
negativity.
minus, plus, minus,
Plus,
minus.
Okay. Alright, so of these signs, we are going to count the sign changes. So the sign changes, not the signs. You're counting how many times it switches from either plus to minus or minus plus. 1,
2,
Dose.
3,
3, 4.
Quattro.
Okay.
How many?
This means we have 4 or
2.
Or 0.
or what?
Settle.
What does this mean? 4, 2, or 0, what?
Possible
Positive real
roots.
roots.
Yeah. Okay. That's part 1.
Part 1.
We got part D. In part D, you're looking at the function with a negative x plugged in. Okay, so p of negative x. So you're going to plug in a negative x into each term, except for what term? Constant. Why?
Because there's no X.
Exactly. And because what does constant mean?
It
Stays the same.
Yeah, so don't change it, then you're breaking rules. Okay.
I'm a rule breaker. I'm a rebel.
Don't do that.
So, you're right, I am cool. Cooler than you.
In your dream.
I'm cooler than everyone here.
Well, Andrew. Come on.
There's a lot of terms.
Such a good
Okay.
Is it possible to be cooler?
So when you plug these in, you're going to simplify. Anything to an odd exponent is going to stay negative. Okay, so any negative raised to an odd exponent is going to stay negative. Any negative raised to an even exponent is gonna go positive. So this one will go positive, but because we're subtracting it, you're subtracting a positive term, so that's gonna be a negative term. This guy is gonna go negative because he's raised to the third power, but we're subtracting it, so that will be positive.
Shouldn't x to the 4 be positive too?
So you subtract.
It makes it positive.
So when you subtract a positive,
So
it's
a whole other day of studying starts Wednesday, finish up on this.
Okay.
So.
And then plus sign.
okay. Over here, this is gonna go positive, plus 3, that's gonna be positive 3x squared.
Then
Negative x and negative 4 is gonna be positive 4x. And then we got positive 4, that doesn't change.
so there's
It
one.
only changes twice.
No, once.
A 1. Yeah, I lied.
Okay, so
It's
one
one.
change means
1.
1 or,
0.
No or.
no or, negative real roots. No or for 1. It's 1, it's 1. 1 all the time. 1 today, 1 tomorrow, 1 the next day. Okay. Now we're gonna make a little
chart.
table.
Trouble.
Yeah, chart.
You.
Chart. Okay, scenario number 1. We have
Okay.
4 positive roots.
That would be correct.
We have 1 negative root. How many imaginary do we have?
None.
None. How do you know?
Because you only
the
have
thing is 5.
Because the thing is 5. But really, how do you know?
because of the
Oh,
leading
fundamental theorem of
exponent.
algebra.
The fundamental theorem of algebra says that the degree of the polynomial is the number of roots it will have.
The
So
degree,
each
that's what
row,
I was looking for.
yes, each row has to total to 5. So we already have 5, so no imaginaries. Okay. Scenario 2. We have 2 positives. We still have 1 negative.
2. And we have 2
Think
And
about
we'd have to have 2 imaginary in that case, because you would need 5. Last scenario. 0, 1, 4. So 0, 1, and that would mean we would have 4 imaginary.
Well, that was
What are you getting?
What's up?
Why? Why?
I like the one with
wait,
0
because there's
million.
one negative. Oh, okay. And the 4 just like okay.
Alright. So we did Descartes' rule sets. Now,
That was rule.
this is where the whiteboards are going to come in. We are going to choose one of our possible rational roots, and we are going to test it until we find a remainder of
0.
0. Once we find a remainder of 0, then that means it's a solution.
Can we just use our calculator?
No. So, in order to test it, you're doing synthetic division. You're going to write down on your whiteboard all of your coefficients. Make sure that you're making an effort to catch if there's any missing terms. You would have to put a 0 as a place filler. And that is not the case here. We have every single term, so you don't have to do that here. But in some situations you do. Okay, so here's how we're going to do it.
Nick.
Okay, Nick, you're going to test 1. You guys are going to test -1. You guys are going to test 2. You guys are going to test -2. You guys are going to test 4. And you guys are going to test
I'm
-4.
on it.
Ready, set, break. Break!
Let's go, guys.
Mark
We
it.
can do it.
I'm gonna miss always.
So we tested -2, it worked. Now we're going to test another one. Let's try 1. So we're going to bring down 1. Multiply. Add. Multiply. Add. Multiply. Add.
What?
Multiply. Add. And we got a remainder of 0. What does that mean?
What?
That means 1 works. You're going to circle it, and then you're going to write it over here because it's an answer. And if you don't write the answer, what are you doing?
Being bad.
Yeah, you're doing nothing. You're just sleeping. What do you like to
I
sleep?
want to sleep.
I'm sleeping. Now, if this is a quintic and this is a quartic, what's this guy?
Trinomial.
Trinomial.
Thirdic.
A cubic.
You said thirdic.
No one's studying their vocab.
I said cubic.
Cubic.
I am.
We heard
I said
trinomial somewhere.
We don't talk
Do we
about
know how
that.
to solve cubics?
Of course
No.
we do.
Sometimes, but not all the time. So we're gonna keep going.
Wait, what? Why? I mean, we already have our positive. Oh, well, we need 3 positive answers.
Don't you worry about
Why
it.
is this so dirty?
Because it was on that.
Say hello to my little friend.
No, it's
Okay, so we divided
Encroaching
once.
on my territory.
We got a quartic. We divided again. We
Get a
now have a
cubic.
cubic. So these numbers are representing the coefficients of a cubic.
We don't have a problem.
We're gonna do it one more time.
Oh, she keep annoying me.
So we only have one more value to test, so hopefully that works. If it doesn't, then we would try to factor by grouping.
Oh, that would
So 2.
be.
Or we could test the same value again. Like we could test 1 again. 1 could work twice. You could get the answer more than once.
Oh, yeah.
So you can
Oh,
test
yeah,
1 again.
multiplicity.
Yeah, multiplicity. That doesn't usually happen.
Oh.
Alright, so it doesn't usually happen like, because I don't make it happen because I feel like it's like confusing. But anyways, this thing's hard enough, right? I don't need to make it like even harder. Alright, multiply.
Goes. 0.
Multiply.
0.
Add.
1.
Multiply.
2.
Okay, we got a remainder of 0. What does that mean?
That means it's a right
Yay!
answer.
Okay, it means it's a right answer. So we're gonna write it down. If you don't write it down, what are you doing?
Wasting time.
You're gonna make it a quadratic.
Now these orange numbers are representing a quadratic equation that we just don't see right now. So we are gonna find it.
Oh.
Now,
X squared plus
1.
0x.
I need to erase a little bit. So can I erase like the black and blue?
Yeah.
Black.
Just scroll.
So I'm gonna take this and I'm gonna turn this into a depressed polynomial. We know it's quadratic because we divided a bunch of times until we got to that point. So the 1 is representing the coefficient of the quadratic term, the 0 is representing the coefficient of the linear term, and then the last one is representing the constant. And because we're finding roots, we're setting this equal to 0 because roots are zeros. Now, we probably wouldn't write it like this because this is weird, right? Weird.
Just get rid of 1.
So we're just gonna go like this. And solve. What's the best way to solve this? Square root property. So subtract 1, square root both sides,
So x equals plus
Just
or
equals
minus.
I. X equals I.
plus or minus
plus
I.
or minus I.
And then what do? You write those down because if not, what is your doing anyway?
What is your
Now I'm writing them individually because I like to count things. How many answers do we have?
5. Yay!
5. Is that good or bad?
That's good.
That's good. Are we done?
Yeah.
Yeah. So the last thing I just want to
Trick
do
me.
is which case was it? 1, 2, or 3?
3.
It was 2.
2. So is this one? We had 2 positives, 1 negative, and 2 imaginary. Now, if you're done with the question and it doesn't match up with one of these cases, something's wrong. Either your Descartes' rule of signs is wrong, which is maybe more probable, or your answers are wrong, probably less probable. Those are probably right. Probably less probable. So we got 2 imaginary, that was a plus or minus I. We got the 1 negative, that was -2. And then we got 2 positive, that was your 2 and your 1. Yay! We're so smart.
No, we're not.
We did it. Now you can check it on your calculator sometimes. If you graph it and find zeros, you'll be able to see the real ones. So you'll be able to see your Kirby thing touching the x-axis 1, 2, 3 times, but you won't see these guys.
Oh no.
Oh no.
I can only imagine.
Okay.